Assalamualaikum warahmatullahi wabarakatuh. Good day to my lecturer, Dr. Matsah bin Haji Salam. My name is Nurul Najihah binti Hamdan. So today I would like to present my assignment 4, which is converting audio data into image. Okay, first thing first is about the introduction. This assignment requires us to test our knowledge in converting audio data into spatial data representation after having a basic knowledge of image processing and also the basic understanding of speech processing. I was assigned to design an approach in converting audio data values into spatial data values and display the output that I obtained after enhancing a better solution. The sample solution that is provided by our lecturer is by mapping point to point, and the proposed solution from me is I mapping through frame to frame. Okay, this is the output for the sample solution 1. The sample solution 1 is mapping based on point to point. The output that we see here is in grayscale, and the pattern it is hard to differentiate due to black and white output. From here, from the close gap point here, we can see the differentiation, but it is hard to interpret which one is the voice audio and which one is not is unvoiced audio. For the sample solution 2, it is mapping based on ZCR, zero crossing rate. The output is also in grayscale, and from here we can see the differentiation, but still hard to interpret because, for example, for the audio number 2, it is very inconsistent output we can see here. Since the audio is inconsistent, which we can see the higher value, the lower value, and the higher value, it is repeating itself, but we cannot interpret which one is the voice and also which one is unvoiced audio. Although we can see the gray area here, but we still did not know either it is the starting point or the end point for the speaker to speak or stop speaking. Okay, this is my proposed solution. My proposed solution is I want to map audio data based on frame to frame. Each frame contains the window size of 256, each of it, and then I will calculate the energy and use it as a variable in converting the audio data into spatial data representation. Next is I will assign the color for energy that I have separated for each frame and compare to differentiate which part has the lower and which part has the higher value for audio assigned. Okay, this is the flow chart. Okay, first thing first, I will read and load the audio file, which is I have 3 different audio that I put into my script, and then I will calculate and also separate the audio file into frame of 256 window size, and then I will calculate energy for each frame that I have separated and find maximum and minimum energy of the audio, and then I determine the color using the energy values obtained. I normalize the energy value between 0 to 1, and then I map the color values into if-else loop statement. I reshape into two-dimensional metric, and then I use the division method to do some contrast for the image to see the better solution, and then I will display the spatial data representation output. Alright, this is the main script. I name it as audio call.m. I'm using the ding.wave, ring 0 to wave, and also window spatial critical wave. I have the 3 sound here. Okay, this is the solution script. I name it as solution.m. Alright, for the explanation of my script, okay, firstly, I'm using the win size 256. It is a suitable win size. 256 is a suitable one, which I will separating the audio files into frame. F is the number of frame produced using square root method, and then I calculate the energy for each frame that I separated using for loop, and I will store the energy into the array of E right here. And then I will find the maximum and the minimum energy for the frame. I call it as half to determining the color for the image output. Next is I assigning the color for the frame of energy that I have separated before this. Okay, since MATLAB is using the RGB color code, then I apply the RGB color code for my script. the color change based on the energy of the audio. From here, you can see the energy greater than half and also the energy lower than the half. For this one, it is a two-dimensional metric and this one is three-dimensional metric. BI1 here is representing red color, BI2 is representing the green color. From here, BI2 representing the green color while BI3 is representing the blue color. When the value of energy is high, the color turns into red. When the value of energy is low, and the color turns into blue. Okay, from here, I normalize the value between 0 to 1 because the pixel value of image used is 0 to 1. If the energy greater than half, the color change around red and green value. But if the energy lower than half, the color change around green and blue value. Next is mapping array produce one-dimensional array with value of one column. I use the reshape function. Reshape is used to produce two-dimensional metric. Pixel value for R is divided by 0.2 to have a better contrast when displaying the output. Before this, the provided sample solution is using between 0.5 and also 0.7, but I'm using 0.2 to make the output look better and it is easy for the viewer to understand. Okay, the color of energy is changed due to contrast and intensity applied. The color that change is turned into red, yellowish, and pink. Alright, this is the output. From here, we can see that the red, yellowish is the one that have the higher energy in the audio, while the hot pink is the lower energy. Okay, we can see from here, this one is the higher, and this at this part it's higher. It's turned into red, yellowish. This one, there's no sound. It is ending point, and there's appear the hot pink color. The conclusion is the proposed solution works so well, and I able to learn that energy attribute able to convert audio signal into image. And then I understand the audio based on energy with the help of color code assigned into it. The slight changes in the script, for example, the contrast or the intensity could make the RGB color change. That's all from me. Thank you so much.